Greetings and welcome to another Math 104 College Algebra and Trig lecture. So today what we're going to be looking at is polynomials. So we're going to be looking at polynomials as far as how to add and subtract them, how to expand, which means to multiply them, and so on and so forth. Okay, so what is a polynomial? A polynomial, poly means many, nomial means terms. So essentially it just means that there are many terms. So we are going to be looking at polynomials in this general sense. So what you see on the screen here, this is kind of how we describe polynomials. It might look a bit abstract at first, and I'll explain it, but it'll make a lot more sense when we look at actual examples. So what's going on here? Essentially, what we're seeing is we have a subscript n times x to the nth power. And then, you could figure out the rest from there. What do the subscript means? Subscript essentially just means that the a's are not necessarily equal. So, for example, A2 may or may not be equal to A1. It's basically just saying that they're different, right? Which basically means that I could have used different letters, like I could have used A, B, C, D, so on and so forth. But the reason that we do it this way is because we don't know how many polynomials are going to be in an expression until we see the expression, right? So this is just saying that there's, there could be however many terms as you want in one expression, and it'll still be a polynomial. And the reason that we have a to the 0 and there is no x multiplied against it is because a to the or I'm sorry, not a to the 0, a0. A0 is our constant. Right? Because if we're going down the chain here, right, we started from x to the n, and then the exponents are descending, right? Then we have x squared, which means that this is going to be x to the first. Well, then that would mean that we have x to the 0 here, and we all know from the last lecture that x to the 0 is just equal to 1, which basically just means that we just have whatever a0 is, so whatever our constant is. Okay. So with that being said, let's look at an actual example here. We're going to try to find the sum of two polynomials. And again, it'll be a little more clear what polynomials actually are when we see them in a real format, right? So let's say I want to add, we have x squared plus 2x plus 6. So that's my first polynomial. That's my first expression. And what I want to add to it is 4x cubed plus 2x squared minus 2x. Okay, so the method at which we do this is we try to do some sort of pairing. Now, if you guys remember when we were talking about sets and when we were talking about whether it was unions or intersections, we were looking at, well, specifically intersections, we were looking to match things together, right? We were looking in one set and then we were looking in the other set to see what elements were the same, right? When we add polynomials, we're kind of doing something similar. What we're doing is we're looking at the exponents and we're seeing, okay, well, when we add these together, do I have similar terms? Do I have, so just for an example, I have a 4x cubed here. Do I have an x cubed on the left-hand polynomial? The answer is no, right? There is no x cubed there. So when I add these together, the 4x cubed is going to be added to nothing because there's no other x cubed that I can add to it, right? So we're going to follow that same process with all of them. So just like we said, 4x cubed gets added to nothing, right? So 4x cubed plus 0, because there is no other x cubed on the left-hand side that we can add. Now we go in descending order, right? We started with the cube, now let's look at the squared. Do we have an x squared in both sides? And the answer is yes. We have x squared here, and we have a 2x squared here. So we can add those together. We have x squared plus 2x squared. Okay, continue going. So now we are looking at the 2x, right? So x to the first, that's the next exponent that we're looking at. So 2x. And do we have an x to the first on the right-hand side? Yes, we have a negative 2x. So we're going to add those together. So we have 2x plus a negative 2x, which is the same thing as minus 2x, right? And last but not least, we see that we have a constant, right? We have a plus 6. Do we have a constant on the right-hand side? Well, yes and no. Technically, yes, right? The constant on the right-hand side is going to be plus 0. So, technically it's there. But when that basically means that we're not manipulating 6, right? So it's just going to be 6 plus 0. And that's it. We're just leaving it alone. So now when we look at this together, we're going to simplify this and we're going to add all the like terms together. So 4x cubed plus 0 just gives me 4x cubed back. We have 1x squared, right? Because the coefficient in front of the x squared is 1. So 1x squared plus 2x squared gives me 3x squared. We're not multiplying, right? So you don't need to worry about changing the exponents. You don't need to worry about adding exponents. The exponent and the variable are staying exactly the same. All we're adding essentially are the coefficients here. So it's just 1 plus 2, and that gives us 3. And that means that we have 3x squareds. Okay, so we keep going here. We have 2x minus 2x, right? If you remember, we had a 2x plus a negative 2x. So that's the same thing as saying 2x minus 2x. So that's just going to give us 0. They're going to cancel out. So I'm not actually going to write anything down for that one. And last but not least, we have the 6 plus 0. So 6 plus 0 is 6. And this is our final answer. 4x cubed plus 3x squared plus 6. Okay, so why don't you guys go ahead and give number 1 on the classwork assignment a shot, and I'm going to write it down here. So number 1 on the classwork assignment should be 2x cubed minus x squared. Well, I'm sorry. Yes, 2x cubed minus x squared plus x minus 5. So that's the first one, right? And what I'm subtracting from it is, and I'm putting the minus sign below it just for the sake of room. So minus x cubed minus 4x plus 3. So plus 3 down there. Okay. So now when we're subtracting, you're going to follow the same exact steps as when you're adding, right? You're going to be trying to pair things up together. And just remember, as a hint for you guys to try this, when there's a subtraction sign, you're going to be applying the subtraction sign to everything in the parentheses, which means that signs may flip, right? We're subtracting the positive x cubed, we're subtracting the negative 4x, and we're subtracting the positive 3. Okay, so go ahead, give it a shot, pause the video here, and then we'll talk through it together. Okay, so hopefully that went okay. Let's go ahead and start by grouping it just like we did with addition, right? So we have 2x cubed, so 2x cubed. And what we're going to do is we're going to group it with the other x cubed, right? So it's 2x cubed minus the positive x cubed, so it just means 2x cubed minus 1x cubed. And that's our first piece of the puzzle. Next up, we have x squared minus, well, there is no other x squared, right? There's nothing that we can really, take away from it. So we just have the negative x squared here. Remember, it's negative because of this piece right here that I just dotted with red. So we just have that negative x squared and nothing's happening to it. Next up, we have the x to the first, right? So we have a positive x minus a negative 4x, which means that when you have minus and negative, it just flips the sign. So we have plus 5x. And last but not least, we have negative 5 minus 3 right there for our constants. So we go through this and we see, okay, 2x cubed minus 1x cubed leaves us with only a single x cubed remaining. Plus a negative x squared is the same thing as a minus x squared. Okay. Then we can combine the x and the 5x, and that gives us 6x. And last but not least, negative 5 minus 3 is still negative, and that's going to give us a negative 8 for a constant. So this is our final answer, and hopefully this is what you guys all ended up with as well. Okay? All right. So we're just going to keep on rolling then. So that was addition and also an example of subtraction. Let's check multiplication here. So I'm going to write the example for multiplication. What I have here is I have 4x squared times, in parentheses, 3x plus 6. Now, before we actually go ahead and attempt this, I want you guys to recall something. I want you to remember the distributive property, which we discussed in the last lecture. The distributive property is a property that holds for all real numbers, right? Just because we don't necessarily know what x is, that does not mean that it's not a real number, which means that all of the properties of real numbers still apply to x. It still applies to our variables, even if we don't know what they are. So our distributive property, if you guys remember, is a times b plus c. And what we do is we distribute the a to both terms, right? And we get a times b plus a times c, right? So what we are going to do here is we are going to take our whole entire term, 4x squared, and we're going to distribute it against the 3x, and we're also going to distribute it against the positive 6, okay? So what's that going to look like? Well, 4x squared times 3x plus 4x squared times 6. Okay, so the way that we handle the first part is we multiply coefficients first. So 4 times 3 gives me 12. Okay, great. Now how do I multiply x squared times x? Well, if you guys remember from the last lecture, and I'll write it off to the side here, whenever we have, and this is why it's important to remember your exponent rules, whenever we have the same variable, and they're being multiplied, but different exponents, we add the exponents, right? And keep the base the same. So the base is still just going to be x, and we just add the exponents. So x squared times x, or x to the first, is x cubed. Okay, so now we have 12x cubed here, and that's the first part of our solution. Next, we have the 4x squared times 6, and because there's no x to multiply against, we just multiply the coefficients, right? So that's just 4 times 6 gives me 24, and x squared just comes down along with it, right? Nothing happened to it, it just stays there, and that's our final answer. That's it, 12x to the cubed plus 24x squared. Okay, so let me go ahead and clear that off. And what I want you guys to do is actually let's go through one other example before I give you the classwork. Sorry about that. So what are we going to do when we have two terms multiplied against two terms? So in the example that we just went through, that was one term multiplied against two terms, right? So let's take, for example, negative x plus 6 times x minus 1. And I'll clean that up. Sorry about that. X minus 1. Okay. Well, if hypothetically this negative x didn't exist, we know how to do this, right? We just did it in the last example. You would take your 6 and you would distribute it to the x and you would distribute it to the negative 1 and you would call it a day, right? However, we have this negative x here and it's being a pain and we don't necessarily know what to do with it. Well, the way that we handle a binomial times a binomial, and binomial means two terms, right? Bi means two, so binomial means we have two terms in the parentheses times another binomial, two terms in the parentheses, right? And the way that we handle this is by the process of foiling. Okay, what is foiling? I'm not necessarily sure if they still teach this the same way anymore, but this is how I learned it, and this is how I feel like it's the easiest to understand. So FOIL is an acronym, and we'll write it over here. So we have F, I'm going to write in different colors for a particular reason, FOIL. And what it stands for is first, outside, inside, and last. Okay, what do I mean by this? What does this necessarily apply to? Okay, when we're talking about first, we're talking about reading from left to right, the first term that is part of the inside of the parentheses. So the first term in the first parentheses is negative x, right? The first term in the second parentheses is x. So that's what we're going to multiply together first. So we have negative x times x, and that's just x squared, right? But it's negative because, you know, it was a negative x times x. Okay, so that's our first term. Now we do outside, and what outside means is we are going to look at the either the numbers or the variables that are on the outside edges of the parentheses. So in this case, it's going to be negative x times negative 1. And what's happening with that? Well, negative x times negative 1 just means that the sign of negative x is going to flip, so we get plus x. Okay, now we have inside. So inside means if we're looking at the inside of both of the parentheses. So 6 and x in this case. So 6 times x is just going to give me plus 6x. And last, we have the last terms. So 6 and negative 1. And when we multiply those together, we get negative 6, right? 6 times negative 1 is negative 6. And the last step of this is we see here that we have an x, we also have a 6x, so we're just going to combine those two together, and our final answer here is going to be negative x squared plus 7x minus 6. And that's it. Okay, so that's how you handle two binomials being multiplied against each other when you're trying to distribute and make sure that everything gets multiplied against everything. And you'll notice everything got multiplied twice, right? We have the negative x got distributed to the x and the negative 1, and also we have the 6 got distributed to the x and the negative 1, right? So that's just how it goes. Okay, so let me clear this off, and now what I want you to do is I want you to give the second classwork assignment a shot, and I'll go ahead and write this one down. So the second classwork assignment is x minus 1 times 5x minus 3. Okay, so go ahead and give that a shot. Again, you're going to apply the same process of FOIL. Give yourself a couple of seconds or a couple of minutes, and then unpause the video when you are ready. Okay, so hopefully that went pretty well for you guys, and it made sense by applying FOIL. So let's go through it. So I'm not going to write every individual step down. I'm just going to talk through it. So we have x times 5x because that's first, right? So x times 5x is just 5x squared. Okay, next up we have outside, so x times negative 3, so negative 3x. We have the inside, which is negative 1 times 5x, so minus 5x. And we have last, which is negative 1 times negative 3, so it just flips the sign of the negative 3 and it becomes a plus 3, right? So nothing's happening to the 5x squared, nothing's happening to the plus 3, and the only thing that's changing is we're condensing the middle, right? We have a negative 3x minus 5x, so we end up with a negative 8x. And that's our final answer. Okay, so hopefully that makes sense. If you have any questions, please feel free to check the homework out first, and then obviously email me if you're still encountering problems. Okay, so there are a few popular cases as far as expanding or multiplying polynomials that you should be familiar with because it'll save yourself time. Essentially, it just means that you can do it out. You can do out all of the, the math that we just did there with foiling, but it's just going to be really time consuming, and this is an alternative way for you to remember. Okay, so the first three are very common for this course and very common for all courses moving on. The last four are not so common. The reason is because the first three are regards to when our exponent is a 2, so squared, and the last four are regarding when we have cubes. And for the purpose of this class, we're really not going to work with cubes too much, and we're never going to work with exponents that are really like higher than a 3 as far as factoring or expanding. Okay, so let's go ahead and take a look at the first case. So we have a plus b squared, and this will end up being a squared plus 2ab plus b squared. And now you might be wondering, okay, well, how did we arrive at this conclusion? And the way that we arrived at this conclusion is by saying, well, okay, a plus b squared is the same thing as a plus b times a plus b, right? And you see that we just have a binomial times a binomial, and you would go ahead and you would FOIL this out, right? And when you FOIL it out, and I'm just going to save you some trouble and just do it for you, so we end up getting a squared plus ab plus ba plus b squared, and we know that ab and ba are the same thing, right? By the by the commutative property of multiplication, they are really just the same number. So that's a squared plus 2ab plus b squared. Okay, so again, you can go through, if you encounter a situation where you have, for example, x plus 1 squared, right? You can go through and you can FOIL all of it out, but it might be easier for you to say, okay, well, in the case of, and I'll write it down here, in the case of x plus 1 squared, my a is going to be my x, my b is going to be 1. So I know that I'm going to end up with x squared plus 2 times x times 1 plus b squared, and that would just be 1 squared, right? And then that's just going to be x squared plus 2x plus 1. Okay, see, it's a little easier when you can follow just the blueprint for it, which is, again, that. Okay. And again, if that doesn't make sense to you, please feel free to reach out. But you can always just go through the normal process of foiling. Okay, so the next one that we have is a minus b, all quantity is squared. Okay, and this is going to look really similar with one key difference. So we're going to have a squared, and the key difference is right here. Instead of a plus, it's going to be a negative. So instead of a plus 2ab, it's minus 2ab, and we still have a positive b squared. Okay. And we can even do a quick example to make sure that this checks out. So let's say we have, for example, 3 minus 1 squared. And yes, obviously we can do 3 minus 1 first and then, go through the process that way. But let's try to, follow the rubric here. So what are we going to end up with? Well, if 3 is my a in this case, right? We see here 3 is a, b is 1. So if 3 is my a, then we're going to have 3 squared here, right? We're just going to follow the blueprint down. So minus 2 times 3 times 1 plus 1 squared, right? B is my 1. And we'll go ahead and write this out. So 3 squared is 9 minus 2 times 3 is 6 times 1 is still 6. So 9 minus 6 plus 1 squared, which is still just plus 1, right? And this gives us 9 minus 6 is 3 plus 1 is equal to 4. And now we can check this by saying, what is 3 minus 1? Well, that's 2, and 2 squared is still 4. Right? So it doesn't matter what the numbers are. It doesn't matter if there are variables there. A minus b squared is always going to be a squared minus 2ab plus b squared. Okay. If you can memorize that, fantastic. It'll save yourself a lot of trouble going into the midterm. So those are the first two popular cases that if you can memorize, all the better for you. The third one is one that you absolutely do need to memorize. This is the only one that I will require you guys to memorize because when we get to factoring polynomials, which is coming up very soon, if not in this lecture, then the next one, then you will be at a complete standstill with trying to factor this if you do not remember this. Okay, so the next case is a plus b times a minus b. Okay. So before I tell you what the end result is, let's go ahead and let's FOIL it so we can try to, figure it out together. Okay, so we have first, which is a times a. We get a squared. Surprise, surprise, right? We generally always get that. So we have a squared. Now we have the outside, right? So FOIL first, outside. We have a times negative b, so minus ab. Then we have the inside, which is positive b times a. So I'm just going to flip just the order of it and just call it plus ab instead of plus ba. Again, it's the same thing. And last but not least, we have b times a negative b. So we get minus b squared, right? And what happens here, we see that the negative ab cancels with the positive ab, and we end up with a squared minus b squared. And this has a very special name, and it is called, aptly, it is called the difference. That's an R, I promise. Difference of squares. And why is it called the difference of squares? Difference because subtraction, right? We're talking about subtraction here, so it's the difference. And it's the difference of squares because we have two squares. Okay, so whenever you see the same two numbers, and basically if you see the same binomial multiplied against itself, the only difference being the sign, so a plus b times a minus b, you're always going to get the difference of squares. And this is very important because when we see that we're trying to go backwards, when we talk about factoring and we talk about the difference of squares, we have to remember that we can go back from a squared minus b squared back to this here, the a plus b times a minus b. Okay, so this is the only one that I really want you to remember. A plus b times a minus b is equal to a squared minus b squared, and I'm going to be hammering that into you guys basically all semester long. Try to remember it now so that way it sticks for the rest of the semester. Okay, the last four popular cases, I kind of struggle to call them popular because they're not necessarily popular, but they can make your life a little bit easier, which is why I want to go through it, right? So the two cases, the two ones that are similar are a plus b cubed and then a minus b cubed. Okay, now this is we're not normally going to deal with cubes, but it's important that you guys see this and have it in your notes in case you do come across it. Okay, so a plus b cubed. This is the same thing as writing, just so I can explain a plus b 3 times multiplied against itself, right? So a plus b times a plus b times a plus b, and obviously that's going to get us more terms than if it were a plus b squared. So what this ends up coming out to be is when you multiply everything out, when you do all the operations, we get a final result of a cubed. Sorry, a cubed plus 3ab squared. And now keep in mind the square here is only being applied to b, not 3, not to a. Okay, so 3ab squared plus 3ba squared. So the difference here is that, again, the square is only being applied to the a. So we have a cubed plus 3ab squared plus 3ba squared plus b cubed. Okay, so that's what it comes out to be. And the subtraction one also looks very similar, with the key difference being two of the signs get flipped. Okay, so we have a cubed and we have plus 3ab squared. So far it looks the same, right? Then this sign gets flipped, so we have minus 3ba squared minus b squared. Okay, I know that these two can be really hard to memorize, and that's why I'm not too keen on calling these quote unquote popular, but you might run across these where you see a plus b cubed and you're just like, oh God, what do I do? Honestly, the best answer for you, if you don't remember this, that's absolutely acceptable. You're just going to have to multiply a plus b times a plus b times a plus b, and you're just going to have to do that. It's not pretty, but it works, right? And the process by doing this is you're just going to pick two of them first. So you're just going to essentially do that and FOIL that out. And then once you get your answers, then you will distribute the a to every answer, like every term that you have, and also distribute the b to every term that you have, which I have no problem going through with you guys if that's something that you want to see. But for the sake of this class, it's not exactly required. Okay, so we're going to clear the canvas there. Okay, so that was those two, and the last two that we have are what are called the sum of cubes and the difference of cubes. Okay, so when we ever have a plus b times, and this is where it gets very particular, a squared minus ab plus b squared, we will always end up with a cubed plus b cubed. Okay, this one here, this should look kind of similar. This almost looks like the result of a minus b squared, right? The only difference is that if it were a minus b squared, it would be a minus 2ab, right? And we just talked about that maybe 5 minutes ago, so just rewind the video if it doesn't look familiar. Okay, so that's, you know, how you should try to remember this. It's almost the same as a minus b squared, with the exception is that there's one term essentially missing. And then the last one that we is quote unquote a popular case is a minus b. So again, the difference here, you see the sign difference. Instead of a plus b, it's a minus b. And we have a squared plus ab plus b squared. And this is going to give us a cubed minus b cubed. So how do you remember this? How do you possibly remember this? Well, as long as you can kind of remember the signs of what you're supposed to get, right? If we're talking about the sum of cubes or the difference of cubes, these signs correspond to these first signs in the binomial, right? So in the trinomial, the sum of cubes, you're going to have 1 minus, and I should write this in red, I apologize, to make it a little cleaner. You're going to have a plus minus plus. And for the difference of cubes, you're going to have a minus, plus, and then a plus. I know it seems really abstract. When you actually start working with it, it'll be a little more apparent. Okay, so I apologize for that, but it's just one of those things where, you know, if you can memorize it, great. If you can't, that's okay. You're just going to have to do all the work out, right? So let's go ahead and finally do a real example that hopefully makes all of this make sense together, right? Okay, so what I want to do is I want to expand, which basically means multiply, multiply throughout, distribute all of the different terms. So I want to expand x minus 1 times 2x squared plus 4x minus 3. So now you can see, instead of two binomials being multiplied, we have one binomial underlined in red, and we have one trinomial, right? Tri meaning 3, which means we have 3 terms, right? So obviously we're going to end up with more terms than we had with the binomial. Okay, So what is our first step? How are we going to approach this? Well, the way that I want you guys to approach it, because the way it's kind of easier for you to think about is, okay, I want to break this up by the binomial. And what I mean by that is I want to say, okay, well, this is going to be equal to x times the whole thing, everything that's in the trinomial. So 2x squared plus 4x minus 3 minus the 1 times 2x squared plus 4x minus 3. And the reason that it's minus here is because it's minus there. If it were a x plus 1, then this would be a plus 1 there. Okay, so you just keep the sign the same as whatever it is in the binomial. And now all we're doing is, now this part should be relatively straightforward. Now we're just going to distribute, right? We're just going to take the x and distribute it to all three terms. And we're going to take the -1 and distribute it to all three terms. And once we've done both of those steps, we'll just combine it and it'll be done. Okay, so let's get rid of the blue lines here. Okay, so let's go ahead and distribute the x. So x times 2x squared, simple enough, 2x cubed. X times 4x, again, now it's just 4x squared, and x times -3 is minus 3x. Okay, so now we have -1 times 2x squared, and basically whenever we multiply the -1 throughout, we're just changing the signs of everything. We don't actually change any values, right? Because it's being multiplied by a -1. So we change the signs, and we get minus 2x squared minus 4x plus 3. And the last step of this is we're just going to look for all the things that we can kind of condense, right? So we have a 2x cubed. Is there a cube anywhere else? No. So we just leave it alone. So 2x cubed is going to be part of our final answer. We have a 4x squared, and we have a minus 2x squared, which means that we can condense those. So what is 4x squared minus 2x squared? We get plus 2x squared. Now we have minus 3x minus 4x, which means we're going to end up with a minus 7x. And last but not least, we have the 3, the constant, right? And there's no other constant that we can add it to, so we just end up with a plus 3. And now our final answer is as follows: 2x cubed plus 2x squared minus 7x plus 3. Okay, so what was our process here again? Again, our process was we split the binomial into two separate distributions, right? We are distributing the x to everything, and then we're distributing the -1 to everything. And after it's all said and done, we go ahead and we condense it all together into our final answer, which again, 2x cubed plus 2x squared minus 7x plus 3. Okay, and that was a mouthful. Okay, let's do one more together, and then I'll give you one more classwork assignment, and we'll check the time because I'm sure that I'm running low here. So what I want you guys to do, or I'm sorry, the one that we're going to do here together is x minus 8 squared. I want to expand this. Okay, x minus 8 squared. Well, this is going to be equal to x minus 8 times x minus 8, right? Now, again, we can do this in one of two ways. We can either go ahead and FOIL it out, or we can just say, we don't want to do that. We want to save time. And you might remember the a minus b squared rule, right? So I'm going to write this one out here. And that way it might make sense with what we end up with. So a minus b squared should be a squared minus 2ab plus b squared, right? Again, since it's a minus b, we have the minus 2ab instead of the plus 2ab. So doing it this way, if x is my a, then we have x squared minus 2 times x, and 8 is my b, right? So 8 plus 8 squared. And this is going to just come out to be x squared minus, and then 2 times 8 is 16, so minus 16x, and 8 squared is 64. So x squared minus 16x plus 64, right? And I'm just going to draw a little box off over here because that is obviously one way to approach this problem. The other way is the brute force method, which is foiling. And so x minus 8 times x minus 8, we can FOIL, and we get, okay, so foiling first, that is x times x, which is x squared. Then we do the outside, so x times -8, which is minus 8x. We do the inside, which is minus 8 times x, and then the outside, right? So minus 8 times x is another minus 8x, and the outside, which is negative 8 times negative 8, which gives us a plus 64, right? Because two negatives multiplied is going to give us a positive. And we can go ahead and condense this. We get x squared minus 16x plus 64. And now you can see either way, you end up with the same answer. One is just a little more straightforward and a little less brute force than the other, but both are absolutely acceptable. And 99 out of 100 times, I will tell you, I don't care which method you use, as long as you are correct in your approach. Okay. So yeah, we have been doing this class for about 40 minutes. Why don't we end off with one last classwork, and that'll feel like a good natural place to stop, okay? So what I want you guys to do is I want you to expand the following. We have x squared plus 2 times x to the 4th minus 2x squared plus 4. Now, again, I know I said earlier we're really not going to be messing around too much with any powers that are higher than 3. For this case, in this case only, it really just helps illustrate that it doesn't necessarily matter what the exponent is as long as your process is the same, as long as your approach is the same. The exponent could be x to the 77th, and your process is still going to be the same exact process, okay? More specifically, we're probably not going to mess too much with exponents that are higher than 3 when it comes to factoring, which will be in the next lesson. Okay, so let's go ahead. I will give you guys a couple minutes, or take a couple minutes rather, try to figure this one out, and unpause the video whenever you are ready. Okay, so hopefully that went fairly well for you. So the process that we're going to approach to this is we are going to split this up, and we are going to distribute the x squared to everything, and then we're also going to distribute the 2 to everything, right? I think that's going to be pretty similar to the 2 examples ago where we had the x minus 1 times, the trinomial. So what we're doing here is we say, okay, well, I'm going to have my x squared, and it's going to distribute to everything in the trinomial. So x to the 4th minus 2x squared plus 4. And now we're going to take our plus 2, and we're also going to distribute it to the same exact thing, right? X to the 4th minus 2x squared plus 4. Okay, so again, the process is we take our binomial and split it up into 2 different parts, and we're distributing both parts to the trinomial. Okay, so let's do this one first, the first multiplication, x squared times x to the 4th. Remember, when you have the same base being multiplied against each other, all we're doing is adding the exponents and we keep the base the same, right? So x squared times x to the 4th, we keep the base the same, we add the exponents, 2 plus 4 gives us 6. Okay, now we distribute the x squared to the next term. So x squared times negative 2x squared. Well, the negative 2 is untouched, right? Because it's essentially negative 2 times 1. So that's going to stay the same. And now it's x squared times x squared. We add the exponents. It's x to the 4th. And last but not least, x squared times 4 is simply 4x squared. Okay, now we go ahead and do the same thing, but for the plus 2. So we have 2 times x to the 4th is 2x to the 4th. We have 2 times negative 2x squared, so that's going to give us a minus 4x squared. And 2 times the plus 4 just gives us a plus 8. And we're almost done here. We just have to go ahead and find all of the like terms, right? So is there any other term here that has x to the 6th? And you say, no, there's only the one, right? So x to the 6th just drops down entirely untouched. Is there any term that has a x to the 4th? And you say, yes, there's 2, right? There's the negative 2x to the 4th and the plus 2x to the 4th, which means that when we add them together, they're just going to cancel, and we have nothing left for x to the 4th. So I'm not going to write anything down for that. Next up, we have 4x squared minus 4x squared, right? We have 1 here and then 1 here. So those are also going to cancel, and we have nothing left, right? So these guys cancel, and these guys cancel out. And last but not least, we have the plus 8. Do we have any other constants? We do not. So we just have our final answer, x to the 6th plus 8. Okay, so hopefully all of that made sense to you guys. If again, after you try the homework or you try the classwork, if it's really not, clicking, reach out to me. Just send me an email, and I'll be more than happy to work with you. Or just wait until class where we discuss the homework problems, and maybe it'll make more sense there. Friendly reminder: office hours have officially started, so please feel free to swing by on a Wednesday, whatever date that is, September or something, if not sure. But either way, this upcoming Wednesday, office hours 4:15 to 5:15, and you can also discuss your questions there on a more personal basis. Okay, so hope all this all made sense to you guys, and that you guys stay safe and healthy through the COVID crisis. And yeah, that about does it. So enjoy the rest of your day/night. All right, have a good one, guys.